Good afternoon. So today I'll be taking you on scalars and vectors, the definition of scalars and vectors, the examples of scalars and vectors, relative velocity. In the next part of this series, we are going to deal with resultant of two or more vectors and resolution of vectors into two perpendicular directions. Definition of scalars and vectors. What's a scalar quantity? We have actually met quantities that no direction was specified. So when we just say the distance of a boy from a tower is 20 kilometers, we don't say the exact point in space or the directional relationship between a boy and a tower. Those kinds of quantities that we mentioned that way are called scalars. Now they are called scalars because no direction was specified, only a magnitude or numeric value was assigned to that quantity. So that is what a scalar is. So a scalar is basically any quantity that is represented by only a magnitude or a numeric value. That's what a scalar is, but there is no direction. But when we come to a vector, whenever you mention vectors, you define the direction of that vector. So when you say a boy is 50 meters away from a tower, you actually meant to describe the exact position of a boy using angles. So a vector quantity is simply a quantity that has a magnitude and a specific direction. Vector representation. So since a vector has both magnitude and direction, they are represented differently. So a vector is represented by drawing a line or signifying the magnitude, then with an arrowhead. This arrowhead now signifies the direction. So you can know the difference because when a scalar is mentioned, you just see a line without any arrow to specify the direction. We knew from our younger times. So when we are younger, we always knew that we had four cardinal points: the north, south, east, and west. So whenever we specify a vector, we actually state the direction this vector is in using the arrowhead. It's either the arrowhead is up, is down, is left or right. This will tell if the vector is due east, due west, due east right, due west left, due north up, and due south is down. But just know that anytime you see a vector, you are obviously going to see an angle. So they'll use a calibration like this and put an angle 90 degrees, 120 or so. So that's a way of knowing a vector. But when you see a scalar quantity, you just see it plain like that. They just say 50 kilometers per hour. But in vector now, you are going to see 50 kilometers per hour. Then they'll now put the angle there, 100 degrees or 40 degrees. Or they'll write not 40 degrees east. Don't worry, we'll talk about this thing in details. And before the end of this class, you're going to understand everything about this concept now. So let's move forward. Let's talk about how to add vectors. So addition of vectors. So addition of vectors actually is actually based on where the vector is facing. So as we said earlier, vectors, direction is respected when dealing with vectors. So let's look at this instance. You are drawing onto a particular bag of rice, Christmas period. Maybe you cannot carry this rice on your chest and you want to pull it to the ground, to the other room. Now you are pulling it to the other room. You are holding it and dragging it. If your brother ties another rope to the bag of rice and does it in the opposite direction, it's going to be harder. The bag of rice will become heavier than the bag of rice. It will now be the bag of rice plus your brother's force. But if your brother comes the same place you are standing, the same direction with you, and does this bag of rice, you realize that it is easier to pull the bag of rice. This is just the simple physics we see every day, and we'll understand this from vectors. This is actually vectors. So let's go technical here. There's a box on a table. Direction, there's east. If east pulls at 90 Newton and west pulls at 40 Newton, we obviously know that is the direction with the larger force that the box will move in. So what force is applied to the box? So the force applied to the box is going to be the bigger force minus the smaller force going in the opposite direction. Why? Because they are in the opposite direction. Let's run through this as fast as possible. So if the forces are now in the same direction, it is obvious you add the forces. So it's very important that you know this concept. So we have 130 Newton this time around when they are now in the same direction. So that is how you deal with addition of vectors. Let's also use another example. You are walking to the market, or you are walking to a pole, and you walk 3 meters forward and you turn back and walk 2 meters backward. What will be your, I'll call it displacement this time around. I'll explain the difference between distance and displacement for those that don't understand it yet. So how far will you be from your original position? That is going to be your displacement. So in real sense, your displacement is 1 meters because you have only moved away from your original position by 1 meters. But how far have you gone all this time? You have actually gone a distance of 5 kilometers, but you are only 1 kilometers away from your original position. Meters, please. Away from your original position. This will explain vectors and this is different between scalars and vectors properly as well. Because if you move 5 meters forward, if you move 3 meters forward and 2 meters backward, you are only 1 meters away from yourself. And this 1 meters away from yourself is called your displacement. But the distance you have gone so far is 5 meters. Okay, it's very important to note the how the vector is going to be represented. So let us say the boy moved 3 kilometers eastward and then 2 kilometers west. So how are you going to represent the boy's displacement? So this is going to be 1 kilometers eastward. The direction of the vector is going to be in terms of the greater magnitude. So which displacement has greater magnitude? That will be the direction of the vector. Just put that at the back of your head. Anyhow you can do it. Let us now deal with a special case. So if the vectors are now inclined to each other, when you talk about inclination, this time around you did not just move forward and backwards. You moved at an angle. You moved at an angle to your original direction. So example now, you were moving eastwards and suddenly you went northwards. So your displacement is going to be the shortest distance between you and your original position and your new position. That's going to be your displacement. And therefore, you cannot just use an algebraic sum. For example, this was 6 and this was 7. You cannot just say 7 minus 6 and you now get 1 kilometers. You cannot just do this and get 1 kilometers northwards. This is not correct. So you are actually going to use a different method to solve this. Using a graph, you can easily get that the displacement is 9.22 kilometers in the direction inclined at 49.39 degrees of AB, or not 40.6 degrees east. These are alternative ways of saying the same thing.